What I'll do is today we're just going to interact about sets so that we can have a general picture about set sign.
Mm.
Confirm if at all you're able to see my board.
Yes, the board is clear.
Okay. And today it seems the network is better.
The network is better.
Just a minute. Okay, so have you tried to check for the definition of a set?
Definition of a set, yes, I did.
Okay. So what is a set?
Mm. So according to what I researched,
Uh-huh.
a set is a collection or a group of defined elements, or you can call them objects,
Okay.
or in layman's language, a group of things that are well defined.
That are well defined. So
Yes.
you are saying a set. Let me just reduce the font of my pen. So you are saying a set is a collection of what?
A group of a collection of elements or objects.
Okay. It's a collection of elements. Okay. Or objects, Okay.
Yes.
That's all.
So these items are well defined.
Okay. Okay. So
Mm.
it says a collection of elements or objects which are well defined.
Yes.
Okay. So what I'll do is I'll say a set is a collection of well defined or defined elements or objects. Okay.
Mhm.
So now I like the way you have researched about the definition of a set because of this word, well defined. Normally, if we say a set is a collection of elements or objects, that's a wrong definition. Or in short, it's an incomplete definition. There should be an aspect of well
No.
defined. Can you happen to have an idea of the meaning of this term well defined?
So when they say well defined,
Uh,
it means what you have in that collection should be of the same group. For example, you can have a set of different types of trees,
okay.
or a set of different types of animals. So the main theme of the set is that what you're talking about, what you have in that set are animals,
Mm-hmm.
but there are different types
Mm-hmm.
of animals there.
Wonderful, wonderful. So, in short, what we are trying to highlight is that this term, well defined, simply means that the element should have a common characteristic, a
Mm-hmm.
common characteristic, okay, or a common feature, okay. So the element they should be related in one way or another. As you have said, you can have a set of trees, okay, different types of trees. Now, a situation where we have trees, okay. We also have maybe the types of rivers, okay, the types of rivers. Also, we have oceans, different types of oceans. Is this a set?
It is a set.
It is a set. Okay, so what is common in these three? Trees, river, ocean.
Trees, river, oceans. They are all natural resources, I think.
I see. Okay. Okay. Normally, this is not a set. Okay. Let me just try
It's not the
to.
same.
This is not a set. Let me try to narrow the example which I've given. Let's say I've got okay, set A, where we have maybe we have a pen, okay, and then from there we have a rock, okay, and then from there I can put a ruler, I can put leaves, okay. So this set A, is it a set?
No, it's not.
Okay. Why?
Because when we go back to our definition, it's saying a set should be a collection of well-defined items.
Okay. Okay. So now let me try to come in. What you are saying is 100% right. The first one, which we are having trees, rivers, oceans. Remember, in terms of rivers, uh, we have also man-made rivers. Huh? However,
Yes.
although I liked your the way you had defended your answer to say since they are all natural resources. Okay. Other than that, the emphasis with a set, what we need to appreciate is that if we give an example of the elements of the objects which are in that set, they need to have a certain characteristic or a feature. So now if we look at trees, river and ocean, they are not related here. There's no any common feature between a tree, river and ocean. Even with a pen, rock, ruler and leaves, there's no any common feature. Okay, but as you said now, if we can talk about, for example, let me just try to raise my body up a bit. Okay, for example, if we talk about set B, where we say we have one mango tree. Okay, have you seen that? We have guava
Yes.
tree. Okay, where we are listing the types of trees which are there. Okay, so this is a set because the common feature which is there is that these are all what we call trees.
Yes.
Mhm.
Yes.
So in short, with the definition, okay, with the definition of a set, don't forget to say as you are defining this term called set, we need to include this term well defined. So mean that a set is not just a matter of correcting or bringing different objects together and you term them to be a set. No, that is wrong. Okay, those things they need to be well defined. There's no way you can bring a human being, you bring a dog, you bring a cow and you say this is a set. No, that is wrong because they are not well defined. Very important. But you can bring different human being. Okay, you can bring a family. Okay, you can bring a family. So it's a set of the family for Mr. Mlemena. So that is a set. Okay, you can bring a family together. You can bring the types of dogs which are there together. Also the types of cows which are there together. All these things will be referred to as a set because you have brought certain animals or something that have same or similar features together. So you have created what we call a set. I'm sure we are okay with that pattern. Do you
Yes,
have,
clear.
do you have any question for me so far?
So far, no questions so far.
All right. Remember, as I've said, today's video is for us to just have that concept about set, okay? That those definitions, we need to appreciate the mind so that as we are building up now, we are just going to be referring to to certain terms. So that's the reason why today's lesson is very important. So now, if we talk about a set, do we use a small letter or a capital letter to represent a set? What do you think?
When presenting a set,
Yeah.
if we use a capital letter,
Okay. Okay. Exactly. We use capital letters. Okay. So we use the capital letters. We use capital letters to represent a set. Okay. We use capital letters to represent a set. Very important. Okay. And then we use the small letters. Small letters to do what? Are you able to guess? We use small letters.
to represent
Come again.
for small letters to represent the members of that set.
Exactly. Exactly. To represent the members or the object of a set. Okay? This knowledge is very important for us to appreciate. To say we use capital letters to denote a set and small letters to denote members or object of a set. Okay. Any question at this stage?
So far we are okay.
Okay. So now, since we have defined the set, we have also gone further to say we use a capital letter to represent a set, small letters to represent objects or members. How about ways of representing a set? Ways of representing a set. Okay, let's try and tackle that part. Ways of representing a set. So I'll write it heading ways of representing a set. Just in case there's a point which you want to write and I'm quick, please, you can remind me so that I can slow down a bit.
Okay.
Wonderful. Remember to say when you meet up with a friend, you are able to recognize to say this friend whom I've met, the name is Melly, the name is Annie, the name is Waria, the name is Peter. Because there is certain things which when our eyes perceive, we're able to say these things belongs to Peter or to Annie or to Mary. Now, how about a set? When you see something, how are you going to know to say this is a set? This is the subtopic, ways of representing a set. How are you going to write a set? Okay? This is a subtopic. So this subtopic is very important because it's going to equip you with an ability to identify, for example, during an exam or during a test, okay, when you have been given that question on paper, how are you going to know to say this question, it's a set question because of the way it has been represented or written? Ways of representing a set. Very important subtopic that we need to appreciate. So, do you know any way of representing a set?
I can try.
Okay.
Let me give it a try. Mm.
Which one? Which one do you know?
I think the common one use of Venn diagrams.
Okay. Use of Venn diagram. Okay. Wonderful. We have one. Okay.
And also by listing.
Okay. Wonderful. Wonderful. Great job by mine. Okay. Okay. So mostly there are four.
Okay.
Yeah, there are four ways of representing a set. So we need to appreciate these four ways. Right? So the one that you have highlighted about the Venn diagram, that one we can put it under a subheading which we can refer to as a diagrammatical representing a set. Diagrammatical way, because there's also number line. And what I can tell you to say, okay, maybe I'll comment when I reach the diagrammatical part. But the first one that I want us to enjoy is describing a set. Okay, describing. So describing a set is also one way of representing a set. Okay, let me just write describing. Okay, describing is one way of representing a set. Remember, at first, actually, it's you who highlighted to say we can have a set of trees. Remember that comment which you alluded earlier on. Eh? A set of trees.
Yes.
So meaning that you are actually describing. Okay, describing where you are using words to highlight about a certain set. Okay, so we say this method involves the use of words. Okay, the use of words to represent a set. So this simply means to say, instead of using a Venn diagram, instead of listing, they can describe. Okay, they can describe so that you know the nature of elements which are in that set. Okay, so example, they can say a set of natural numbers. Oh, let me do this. Just a minute. I'll start with I'll say set B is a set of natural numbers which are natural number, or let me just say natural numbers less than 10. Okay, natural numbers less than 10. Set B is a set of natural numbers less than 10. This simply means that we have described set B. Okay, so just by reading this statement or this sentence, you can agree with me to say we are able to recognize to say what we are talking about is a set. Any question for me?
No.
Okay, I can move.
Yes, we can move.
The second way is called listing. Okay, listing. Maybe let me try and ask. If you hear the word listing, what comes into your mind?
When you list,
Uh-huh.
how can I put this? When you list, it's like you sort of write down or jot down.
Okay. So now, check. When you describe, you say set B is a set of natural numbers less than 10. Okay. This sentence has consumed in a word form the elements of this set. But when listing, you need to write the individual elements of a set. So this method involves writing individual elements. individual elements or objects. Okay, very important. Individual elements or objects of a set. Okay, so once they tell you to say list set A, it means to say our objective at that particular time is to list or to mention the individual element of a set. Okay. In this case, we can say we have since we have set B, so we can say B is equal to, okay, we need now to list the natural numbers which are less than 10. So we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, remember natural numbers, these are counting numbers. So mean that we have listed numbers which are less than 10. So this is called listing. Okay, where we are writing individual elements or objects of a set. Any question this one?
We are okay.
Okay. So remember to say ways of representing a set is very cardinal as a mathematician to have those ways in which you can perceive to say this is a set question, that's not a set question. Very important. So we need to appreciate. Okay. So what I've done is I've actually tried to go or to start from something that we know so that we can go to something that we don't know. Fine. Because these things are also there in secondary levels actually, but they are very cardinal. They are more like an atom of a set. Okay. So the third way of representing a set, do you have an idea? Okay. So I'll say set builder notation. Okay. Set builder notation. Just a minute. We use a red. Set builder notation. Set builder notation. Are you also writing these to my notes?
Yes, I am.
Okay. As I've said, if I try I'm too quick, please remind me so that I can slow down.
No, for now we are okay.
We are okay. Huh? Okay.
Mm-hmm.
Have you ever heard about this animal called set builder notation?
Set builder notation.
Yeah.
I came across it,
Okay.
but I didn't read much.
Oh yeah. Okay. So normally a set builder notation it is a way of representing a set that involves the use of interval notation. Okay.
Mm-hmm.
Okay. So I can say this method, or I can say it is a way of representing a set using set of numbers between a lower limit and an upper limit using endpoint values. So let's try to digest this simple definition here. Okay. So this one we are saying it is a way of representing a set using set of numbers between a lower limit and an upper limit using endpoint value. Okay. Are you done writing? Can I go ahead to the explanation part?
Yes, I'm done.
Okay. So let's try to interrogate this so that at least we can have an idea when we say set builder notation. So they are saying, or I'm saying it's a way of representing a set using set of numbers. Okay? So let me just end here. I'm interested first of all with this word sentence here. Set of numbers, set of numbers. These three words, set of numbers. This simply means that set builder notation involves only numbers. You cannot put books, okay, pens, trees in a set builder notation. It is impossible. The only thing which can be there are numbers. Okay? So meaning that I want you to know to say as far as set builder notation is concerned, it's make use of numbers. It uses numbers. Okay? Now, other numbers, what else are we supposed to know? Okay? So using set of numbers between a lower limit and an upper limit. Okay? Between a lower limit and the upper limit using endpoint value. What do we mean to say a lower limit and the upper limit? Remember to say we have highlighted to say we'll be using set of numbers. So those set of numbers, they will be the smallest number and the biggest number. So that smallest number we are referring to as a lower limit. We are calling it to be a lower limit, which is the smallest number. That highest number is the one which we are calling to be an upper limit. Remember, we are actually saying we are using the endpoint value, okay? The endpoint value. So if you have a set of numbers, okay, which one are your endpoint value? Your endpoint value is 1, the smallest number, and the highest number. Okay, highest number. These are your endpoints. Okay, so now this colleague of ours called set builder notation, he's saying I make use of a set of numbers between a lower limit and the upper limit using endpoint value. So this is the concept about set builder notation. I don't know whether if at all you have gotten something.
Yes, I have.
Okay, now remember now. For us to indicate the lower limit, which is the smallest number, and the upper limit, which is the highest number, there are certain, I can say, there are certain things in mathematics which can help us to realize this way of representing a set. Okay? Those are what we call inequalities. Those are what we call inequalities. Inequalities will help us to denote the smallest to the highest an inequality. So meaning that a set builder notation always has the inequality sign. Okay, so I'll say not. A set builder notation always, or let me do this just a minute. So set builder notation must be written with the inequality signs. Okay, a set builder notation must be written with inequality signs. Okay, so meaning that we are also saying The inequality signs, inequality signs helps us to denote the lower limit. The lower limit, remember I've said the lower limit in layman's language, smallest number, and the upper limit. The upper limit, of which I've said layman's language, the upper limit, we can say the highest number. The highest number. Upper limit, I'll say highest number. Okay. Are you done writing?
Yes, I am.
Okay. So now, since we have said to say set Bayesian rotation, make use of the inequality signs, and I've gone further to highlight to say the inequality signs helps us to denote the lower limit and the upper limit. So what are these inequality signs? Do you know the inequality signs?
The inequality signs.
Yeah.
I'm thinking, is it the negative and the positive?
Okay, not really, not really. So let's try to dive into the inequality signs so that we can appreciate them. So I'll say below are the inequality signs. So now remember, these inequality signs. Remember the course outline. The course outline, there are a lot of topics that has a component of inequality signs. So mean that once I highlight them here, I'm actually expecting to say when we start dealing with those topics, I'm not going to highlight them again. So it will just be a cruise. We'll just move. So mean that it's important for us to revise. So these inequality signs, we have one, we have this symbol. Do you remember them?
Oh, yes, I do.
Wonderful, wonderful, wonderful. These are the inequality signs which you are talking about. We have this, we have that. So this is a greater than, this is a less than, this is greater than or equal to, this is less than or equal to. Okay. Tell me when you're done writing.
Okay, I'm almost done. Okay, I'm done now.
All right, okay. So these are the inequality signs which are there. These are the only inequality. There's no other inequality signs. Okay? So meaning that we are saying a certain notation make use of these symbols. Okay? These symbols are there to help us in terms of highlighting the lower limit number and the upper limit number. Very important. These, okay? Of which the first one is called a greater than. A greater than. Okay? A greater than. Do you know how to identify or how to differentiate a greater than from a less than?
Yes. I just use for me, I use my right hand.
Wonderful.
Whatever is on the right is greater, on the left is lesser.
Wonderful. Niyo inefyeyo. Yakumvye.
Fine.
Tapwa. There's nothing wrong with even trying to memorize to say greater than looks like just your hands. Wapita up. Very important. Aye. Okay.
Yeah.
So mean that there's no need of me pressing emphasis there. Okay. But the only emphasis
No.
which I want to find out is, are you able to highlight the difference between greater than and also greater than or equal to? Do you know the difference between these two?
Yes, I do.
Okay, which is?
Between greater than or equal to.
Yes.
So if we are given a number, for example, we're given a 2.
Uh-huh.
So when they say greater than or equal to, it means that the number that you've been given is also part of that set.
Wonderful.
Is that correct?
Very much correct. In fact, it's excellent. Okay. So, in short, you have summarized everything. In short, you have no challenge here, right? About in terms
No.
of differentiating this, eh?
This we can.
Wonderful. Then let's go back to St. Peter notation. This our coding.
Yeah.
Let's try now to enter inside and see how this coding will appear. Okay. Remember, we are using the same example where we have described to say set B. Set B is a set of what natural numbers are in?
Natural numbers, yes.
Yes, yes. So let's continue with this same example. So now, what I'll do is underneath here in your book, that's why you write your exam point. But for me, I'll come this side, this part of my board. The reason why is because I want, when I'm explaining, I'm referring to our notes here.
Okay.
But just give me a feedback. Is the font too small, or are you okay with the font?
I'm okay. Me, my eyesight is very sharp.
Oh yeah. Okay. Okay. All right. Wonderful. Wonderful. Okay. So if that's the case, then that is wonderful. Let me just move it here a bit. Okay. Like that. So now, remember we are talking about set what?
Set B,
Set B.
which
So
is a set
what
of
should I
natural
write?
numbers.
So what should I write?
So capital letter B.
Wonderful. That is the first thing which I was actually interested in. Capital letter B, the first. Right? And then we'll say equal to. Okay? And then we'll bring these brackets, of course. So now, remember, we are saying set B is a set of natural numbers between, or which are less than 9. Right?
Yes.
So now, with set Boolean notation, always, you need to choose a letter of your choice. That letter of your choice will represent the types of numbers that you have been given. That set of numbers that you have been given. Remember, with set Boolean notation, we said it's all representing a set using set of numbers. Okay, so we have been given a certain set of numbers. In this case, we are dealing with natural numbers, right?
Yes.
So now you need to choose any letter of your choice to represent that set of number. So now I can use X. Okay? I can use X. So meaning that I'll say set B is equal to X. Okay? Thereafter, I'll use this full column. full colon, sorry. What does this mean
Yes.
in mathematics?
Such that.
You are a mathematician, yeah?
We are trying.
Itose muri asuka.
Tayari sama calculus.
Okay, so this is such that it is. Okay, such that. So now we will now go to inequality signs. The reason why we need to use inequality signs is so that we can show the lower limit and the upper limit. So remember,
Okay.
yes. So remember we said beyond notation, there are a lot of ways in which you can write it, but the meaning can be the same. Fine. So what I'll do is, if I want, I can say x such that this x should be less than 10. Have you seen what I've done?
Yes.
And then comma, after saying comma, I need to highlight this x. This x is representing what? It's a member of what numbers?
What?
So we say x is a member of natural numbers. Have you seen what I've done?
Yes.
So by writing this, any person who is going to say, okay, since x is less than 10, and then this x is a natural number, then you're talking about numbers like 1, 2, 3, 4, up to 9. Sorry, yes, up to 9. So this is 10. Or someone can say b is equal to, okay, x, such that x is less than or equal to 9. Have you seen here?
Yes.
X is less than or equal to 9. This is the same language, yeah? Have you seen that it's the same language?
Yes.
Or if you want, we can say b is equal to, set b is equal to x such that, now let me use two numbers, okay? Two numbers. I know to say the numbers which are there are between 1 and 9. Okay? So meaning that I'll say such that 1 is less than equal to x and x is less than equal to 9 and x is a member of natural numbers. I can use this. Have you seen that?
Yes.
Or if I want, I can say set b is equal to x such that 0. Once I use 0, remember 0 is not part of set bi. Then I'll just use less than, not less than equal to. Have you seen that? Less than x. And then I can use again this less than and then I put a 10 there. Then we say x is a member of natural numbers. This is the same language here. I don't know. Are we on the same page?
We are on the same page.
Wonderful.
It's now getting interesting.
Okay. Actually, mathematics is supposed to be enjoyed. Okay. When you are done writing, update me.
Okay. Okay,
You are done?
I'm done now.
Wonderful. So this is about set via notation. So mean that once you see a question given this format, there's no any other topic. It's a set. Okay? It's a set. Ways of representing a set, very important. We need to know the ways. So I can go to the other one.
Yes, we can move on.
Okay. Let me try to increase the font a bit. Okay. Okay. So the last one, the fourth one, since I said there are four, okay? It's diagrammatical. Diagrammatical way. Okay? Diagrammatical way of representing a set. So under diagrammatical way of representing a set. Okay? Under diagrammatical, remember, there are two other things. Okay? There are two ways of representing a set using this method. Okay? Two ways of representing a set using this method. Just a minute. This is DII. Are you there?
Yes, I am.
Yes, this is supposed to be DI, diagrammatical. DI. Okay? Okay.
Okay.
So there are two ways, okay, of representing a set using a diagram. Okay? So this method, of course, involves showing a set using a diagram. Mind. Okay? So I'll say, okay, this method involves the use of a diagram, when representing a set. Okay? Of which it is in two ways. Fine. There are two ways of representing a set using a diagram. One, the one which you said, a Venn diagram.
Diagram.
A Venn diagram. So how can we represent that set that we are discussing, set B, using a Venn diagram? How can we represent it? Do you have any idea?
Using a Venn diagram. So they say every set. I don't know if this is the correct, but they say every set exists within a universal set.
Wonderful. Very important key point which you have highlighted. Okay.
So we're going to have one circle, which we're going to label as set B.
Okay.
Then inside that circle is where we're going to now list a set of natural numbers.
Okay.
Yes.
Which I've done. Next.
Then outside, that's why we're going to have our universal set.
Okay.
It will be more of a square shape.
A square. Okay.
We label it. Yes, we label it as a U.
So mostly we don't say a square, it's a rectangle. Why?
Oh, it's a rectangle.
Yes, it's a rectangle. Now,
okay.
Although the difference is minimal because they're all plain figure with 4 dimensions, with 2 dimensions, sorry. Now the only thing which is different is that with a square you have equal sides. Now with this rectangle you have only this. These are different time. That's the only.
Okay.
Yes. Okay. Indeed. So the Venn diagram, there's no problem. Why?
No.
Because we are just discussing ways of representing a set. Right? Then
Then that's it.
yes. So the other one is using the number line.
Okay.
Do you remember this animal called the number line?
A number line, yes.
I can assure you, once you are done with number line right now, please, you need to like it. Because under A level, there are a lot of questions that comes under number line.
Okay.
Yes, it goes deep. I'm telling you, this number line. You are just seeing the way it is, but you may find that even in other topics, there's an aspect of a number line. Okay?
Okay.
There's a topic, if we enter under quadratic, there's an aspect of a number line as one way of coming up with a solution or the values of x, but we'll reach to that topic later on. So this number line, remember, what's the number line?
A number line. This one.
Okay. For example, if maybe there is a young person, I understand to say you know about number line, but just imagine you are explaining to someone maybe who is in grade 6 or 7 to say, you're my chief, number line is so. How can you explain it in your own understanding?
It's like it's a straight line which has values from it has values of both positive numbers and integers.
Chapwa, and
Okay.
including a zero.
Oh yeah, including a zero.
It's just a straight line with the positive and negative numbers including a zero. Chapwa. Right. Okay. So there's no need of me writing this definition. I'll just go direct. Okay.
No, we can just go direct.
Okay. So this is number line. I've written it right here. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me move my board. 10, -1, -2, -3. Okay. Okay. So with a number line, the initial concept which I want you to appreciate is this. Remember, I've said to say you need to like this small subtopic called number line. Okay? Because you're going to enjoy it. And you need to make sure that you are able to put it in your mind in such a way that when we start enjoying the beauty of numbers where we are calculating the values of x, you need to appreciate this number line. Okay? So now with a number line, at the end, there is always this line. What do this two arrow mean? Do you have an idea?
The two arrows.
Hmm.
They mean what's this? Is it infinite?
Come again?
The two arrows.
Hmm.
The two arrows, they mean the numbers can go on and on, or
Okay.
we can say they're infinite.
Wonderful. Wonderful. So meaning that, since you highlighted to say number line has positive and negative numbers, so
Mhm.
the numbers which are going this side to the positive side, they can just be going. So this arrow, this to the positive side, it is the positive infinity. Fine. This is a positive
Okay.
infinity. And that's a symbol for positive infinity. So this explanation which I'm giving you, it is useful when we start concentrating with the number line. Of course, since set there is number line, you need to know
Mhm.
the line, but I'm just highlighting to you. But we did much on the number line. Okay, so this part is called a positive infinity.
Okay.
This part is called a negative infinity.
Okay.
Yes. So you need to appreciate to say we have positive infinity, negative infinity. We can just be going with the numbers. We need to appreciate that. Okay. So now, how can we show to say the numbers which we are interested in are the natural numbers which are less than 9? Okay. So what
Mhm.
you do is this. Remember those numbers are 1 up to 9, right?
Yes.
Mhm. So you go on top of 1, you put a dot. Make sure that dot is shaded. This means something. Okay. Also, you go on 9. Make sure that it's what? Shaded. And then you connect them with a line. You use a ruler. You just
Okay.
me. I don't have a ruler right now. Use a ruler when connecting. So this is set B.
Okay.
Okay. So now, for the sake of the number line questions, the subtopic that we are going to have as we are moving in. Okay. So okay, let me just get a feedback. Are you writing or you are listening?
I'm done writing now.
Okay, all right. So remember I've shaded time and then I've said start at
Yes.
1. In your own
Mm-hmm.
understanding, what can be the meaning of shaded?
The what?
I'm saying, remember on top of 1 here, I said in line with 1, write a dot, you shade it. On top of 9, in line with 9, write a dot and shade it. What can be the reason
Oh,
or what is the meaning of shading this dot?
the reason for shading?
Yes, the dot.
Uh, I think the shading shows what is contained in the set.
Okay, okay, wonderful. Okay, let me just try to enhance that explanation. Remember, we are talking about natural numbers
Oh,
which are less than 10, of which those are 1 and 9.
yeah.
So we have shaded 1 and 9 because these are part of the answers. Right? So the shading, it means that the number which is down here is part of the answer. The number there is part of the answer. And this simply means it is a closed interval. A closed interval. Even this one simply means that it is a closed interval. But there's also other ways in which we can show to say this is not part of our answer by just writing Ekaseko but do not shade it. Have you seen that? Without shading it.
Yes.
So if we do not shade it, it means that this is an open interval. Open interval simply means to say that number which is in line with the open interval is not part of the element or the members of that set. Very important.
Okay.
Yes. But we put it as a heading on its own so that we dig. Because even this cross interval has got its own symbol, which is this. Okay, this is a cross interval. Open interval, we use this kind of brackets for open interval, for close interval. Once we start this, then the beauty of numbers has started. A level has started. Remember, this is not under syllabus D. So, any question for me?
On this one,
Mm-hmm.
on the number line, you can just go back to the part of shading.
On the part of shading?
Shading, the part where you were explaining on shading.
Okay. So on the part of shading, I've said when we draw a circle, a small circle like this, and then you shade it, it simply means that that number which is underneath that circle is part of the members of a set. Okay? Even this side.
Yes.
So now, since we are saying set B has the members or the element from 1 up to 9. So we'll shade on top of 1, we'll shade a dot. On top of 9, we'll shade a dot. A Kaseko will shade it. So meaning that what we have shaded here, the numbers are part of the element of the given set. Other than that, I said the opposite of this is not shading, just writing the Kaseko on top. So this simply means to say the number which is below there is not part of the set given. Okay? Remember, it's the same as saying less than or equal to, those concepts. Okay? So if we shade, there is an equal to aspect. So that equal to aspect under number line, they are called the close interval. But I'll give you the notes later on. This is just for your sake, just in case you want to go ahead of me to just arouse that appetite. Okay? And then
Okay.
the open circle here is called open interval. Okay? Open interval. Open interval simply means to say the number underneath there is not part of the element or the members of the given set. And the way in which you are going to say this is an open interval, we use this bracket. Closed interval, we use this bracket. Yeah. So, for example, in this case, we have said 1 up to 9. These are our answers. So, we'll say the answer is 1, comma 9, 1 to 9, and then close interval. Have you seen? Close interval, 1, comma 9, close interval. So, once you write this, a fellow mathematician will pick up the language to say what my colleague is trying to communicate is this and this on the number line. Okay? I don't know whether you have gotten it.
Yes, I have now.
And you're okay.
Yes, I'm okay.
Wonderful. Wonderful. Okay. Okay. Now, these are the ways of representing a set. So, do you have any question about ways of representing a set?
No, these ones we are okay.
You're okay, eh?
Yes, we are okay.
Okay. So, what I'll do is, with what we have done, I'll forward something. And then, just in case if I tell you to say I'll forward and then I don't forward, please remind me.
I remind you, okay.
Don't kulatira ati ababa mudara abafesi twamu. Remind me, please.
I will remind.
M1.
I will remind. That one, when I have time, I'm going through.
Yes, very important, very important. Actually, that's what mathematics demand us to be doing. Okay, and then
Yeah.
apart from this, there's what we call set operations.
Yes.
Do you know what set operations are?
Set operations.
Mhm.
Oh, no.
Okay, set operations. For set operation, I'll just give you a summary. Okay, but just go deep and research and know them. But otherwise, on the next lesson, we are going to use them. So set operation, we are talking about intersection set. Intersection, the symbol we use this. We are talking about the union. Do you remember this?
Okay, the union set.
Uh-huh.
Okay. The
Complement.
intersection. Yes, the complement.
Uh-huh.
The empty set.
Yes. So mostly we set operations, we need just to concentrate on these three. Okay? These three.
Okay.
Uh, these three. So set operation is more like for us to have multiple sets, okay? We need something to link in between those sets.
Mm-hmm.
For example, in ways of representing a set, we're just using a single set. Now, what if we have set A and set B? Okay, there's a lot of questions that can be asked here to say find A intersection B, find A union B, find A complement intersection B complement, lot of questions. So these are what we call set operations. So we need to appreciate them. I'm
Yes.
So what I want you to do is, in terms of set operations, just go through those books which I told you so that you can write the notes. But let us discuss them so that it can be easy for you, even as you are going through, it will be easy for you to comprehend.
All right.
What is an intersection set? Do you have an idea?
An intersection set.
Mm.
This is it's it's where we've been provided with not one set, maybe two or more sets, and we have to find the common members of this set.
Wonderful. So it's a set that contain, okay, members that are found in both of the given sets that are common in all of the given sets. So if you are asked find A intersection B, you're talking about the common members, the common element which are in set A and they are also in set B.
Yes.
Union set.
So a union set is a summation of all the sets that you've been given.
I like
Of all the members.
I like the use of the word summation. Okay?
Okay.
Okay. All right. So it's a summation. Okay. In layman's language, you can say summation, but we need to be careful because a summation
Mhm.
you can end up having a single number because a summation simply means that it is a sum, mine. The sum that we get after adding.
Yeah.
Okay. Yeah, but indeed,
Okay.
a union it's a combination of all the elements under discussion. All the elements
Mhm.
which are in the given sets, we bring them together. Of course, as we are doing the union, we need to note to say, just in case there are those intersecting members, those members which are found in both of the sets, just in case they are there, those types of elements or members, we just need to write them one sign.
Yes.
There's no need of repeating them. Since we have said union, we are combining. Okay? If the question is saying find A union B, we are combining the elements or the object in this set and that set to bring them together. Now, those elements which are common in both of the sets, do not write them by repeating them. No, just write them
Okay.
once. Very important.
Okay.
A complement set.
A complement set is when they say okay, so I use the same example.
Yes.
A intersection B complement. So they're saying everything else which is not in the intersection of A and B.
Wonderful. Fine.
Yes.
So a complement set is a set that contains elements which are not found in the given set. I know.
Right.
They are not found in the given set, but they are in the universal set. In the universal set.
Universal set.
So once you comprehend this, then set operation is done as well. Right?
Okay.
So now, today, as I've said, it is the main reason why for today's lesson is for us to have some ideas, some content about the set, background information that we need to appreciate. So mean that as we start now, the next lesson, okay, we'll just be cruising now with the calculations. So this is just the background information which I wanted to find out if at all you know them, okay, which I wanted me to share them with you so that it can be easy for us to start calculating. Because do you know the reason why people fear mathematics? It's because they rush into calculation forgetting the concept. How can you solve something that you don't know? It's hard. So always, the first thing to solve mathematics, know the concept. Once you know the concept, the second thing is you now start practicing the concept by calculating your hand now. That's why your hand now will come in. Because now, remember the hand will be writing which the mind is interpreting. So the mind cannot interpret something which is not there. That's the reason why a concept first needs to be in your mind. And actually, with mathematics, how it is once you see the question, before you even touch the pen, the mind need to start moving to calculate for you, and then the hand will just be following. So please appreciate those concepts. I'm.
Yes, sir.
Is there any question for me?
Today's class has been clear.
Okay.